Last video, I mentioned the method of completing the square. When you solve a quadratic, you can force it to look like a something squared equals a constant, so that the square root, you can do that by manipulating the algebra. Last problem we did, just to remind you, something like this number 11 here. You take your quadratic equation, move the constant to the right side, which made it a positive 32. Let me just show you that again. To complete the square, you have to have a 1 coefficient on your first term, on your squared term. So if it's not, you have to divide through by that. But here we're good to go to start out. Then you half the middle term and square it. This is the magic of the process. So it's half the middle term, or the x term, and then you square that amount. Okay, in this case, it's kind of a special case because it's a 4. When you half 4, it's 2. And then when you square the 2, it's back to 4. So it's the same thing, but just by a special case there. It's not always just that number. But so I've added 4. 4 is the completing the square value. It's the magic number that makes this a perfect square trinomial and helps us to do this. So when I add 4 to the left, I must add 4 to the right to keep the balance, making that side turn to 36. Now, whenever you add that number in, it guarantees that this side is then factorable. So we can factor that down to an x and the 4 down to a 2. And you can see if you were to FOIL this out, the first is the x squared, the outer is 2x, and the inner is 2x, making this 4x, and the last times last is the 4. So this multiplies to be that. So we're not changing any value, we're just manipulating or changing the look of the algebra so we can do a process. So anyway, x plus 2 times x plus 2 is x plus 2 to the second, right? So it'd be factors into x plus 2 squared, and then we said that equals 36, and there we have it. Now it looks like a something squared equals a constant, and that's why we can square root to solve the square and square root cancel each other out. We always say plus minus of whatever we took the square root of this side, and then we finish that problem out. And we got answers of 4 and negative 8. All right. Let's do one number 12. Tougher. You can see I don't have a 1 coefficient. That always makes these quadratics much tougher, but the process is the same. So we start by throwing the constant across the line. All right, then we have to have a 1 coefficient. So whatever's in front of the x squared has to be divided out equally across all terms. Makes a fraction. We don't like that. You know, fractions cause much grief, right? No one likes a fraction. Okay, so now we're ready to do the next step, which is the magic step, I called it, which is half the middle term squared. So again, we half and square. So what is half of 3 over 2? Okay, how can we figure that out? We can say 3 over 2 times a half. That's one way to think of it. 3 over 2 times half of that would be 3/4. So 3/4 would be half of the middle term. Then square that, which would square the top and the bottom, 9/16. So 9/16 is our magical value. So we add that to each side. And then to the 1/2, I'll also add 9/16. Feel free to hit your calculator up for this. So that's fine. This side is guaranteed to factor. You know, if you've added in the correct magic number, it factors every time into a repeater. And the values that you bring down is the square root of the first number, which is always just that variable, x to the first, and then the square root of the constant, which takes us back to the 3/4. We had that number earlier. So square roots of the ends, and then the sign of the middle. And you can check that out just to convince yourself this works every time. If you FOIL this quantity times itself will equal that. And it does every time that you use this method. Now, what is a half and 9/16? Again, like I said, just use your calculator if you like, but that would be 8/16 and 9/16, which is 17/16. Now we've got it in that order that we earlier when we used the square root property. So square root each side. And then that cancels that squared out, makes x plus 3/4 equals plus minus this side, square root of 17/16. Then we clean this a little bit. We can throw the 3/4 across the line, and x equals negative 3/4 plus and minus. I'm going to break this apart because you shouldn't really have a fraction radical. You should always break the top and the bottom up if it's left like that, and then make the denominator rationalize. You never leave a radical or an imaginary in the denominator of a fraction. It's just one of those reducing rules. Well, we're here because 16 is just 4, so that reduces. We have negative 3/4 plus and minus 0 to 17 over 4, and we can leave it like that, or we could consolidate it under one fraction. There's no amount you can bring those together. Either one should be okay. All right, fun, right? Lots of fun. We don't really complete the square that much. It's kind of a neat little trick there, and it does always work, but sometimes it's more complicated, you know, because of the fractions, and there's an easier way, I would say, to do this process called the quadratic formula. The quadratic formula works for all quadratics, whether it was factorable or not, or square root property, or simple or grand with fractions, any type of equation, quadratic. It's the standard formula. It works for everything. Now, why does it work, you might ask? And I'm going to show you, I have this messy algebra. I think I'll start over on a clean sheet and demonstrate where the quadratic formula comes from. You may have seen this in your past somewhere, this little formula, negative b plus and minus square root of b squared minus 4ac all over 2a. Well, why in the world would that work to solve a quadratic, you might ask? And maybe somewhere in your past this was a bonus question that your teacher asked you. Why does that formula work to solve a quadratic? So I want to show you why it works, since we just finished talking about completing the square. Maybe you don't care why it works, you're just glad it does. But this might help you appreciate it a little bit, where it comes from, and if you had to derive it, so you could use the formula. So what it is generic use of any quadratic, ax squared plus bx plus c equals 0. That's standard form for a quadratic, right? Where a, b, and c could be any real numbers. All right, so let's say we solve it with just this generic way, and I'm going to show you how it gets to that formula. And if you want to pause the video and try it on your own, I would just love for you to do that and see how it goes. But we can use complete the square. This problem, like we just say, what was that process? Step 1, we throw the constant across the, makes that negative c. Step 2, if there's a coefficient in front of the square term, we always have to divide that out. So just assume it is 1. Whether it's 1 or not, this will represent it. So I'm going to divide by that coefficient a all the way across. So how does that look? What could we reduce that to? So these two would divide out and leave x squared plus b over a x equals negative c over a. Okay, you can see it's starting to evolve into that just a little bit, maybe you notice. Then what do? We take half of this middle term and square it. That's how we figure out what to add to each side. So what's half of b over a? Well, let's go to the side here. b over a times a half would be b over, that would be 2a. And then we square it, right? We half the middle term and then square it. So that would be b squared over, that would be 4, and that would make that a squared. So that's what I'm going to add to each side. So it'll be x squared plus b over ax. What do we have here? I'm adding in this special magic that completes the square. And I have to add it to each side, right? To keep the balance. All right. Now, this should be guaranteed to factor. By completing the square, we know that brings down this x, this sign, which is plus, and then what's the square root here? Take it back to its square root would have been b over 2a. We had that over here earlier. The square root of that value is, before we squared it, b over 2a. Now, can I add this fraction? I would need a like denominator. The LCD would be 4a squared. I need a like denominator to add fractions. So let's see, that has been changed by a 4 and an extra a, so I times the top also by 4 and a. There's the negative 4ac you see in the formula, right? It's showing up a little bit more all the time. All right. Then these are like denominators now, and why not write it as b squared minus 4ac? Let's see. Let's turn it around. Look a little cleaner. We could leave it minus 4b squared, but it looks better that way, over 4a squared. All right, so what have we got now? We've got it in the form to where we can use the square root property. So I square root. That's where that comes from in the formula. Then that cancels out, bringing out x plus b over 2a. Remember the plus and minus when you take the square root. I'm going to divide this up into top and bottom, so square root of b squared minus 4ac on the top, and the square root of 4a squared, which, we're in luck, happens to be all perfect squares. The 4 comes out as a 2, and the a squared comes out as an a. There's where the 2a part comes from. So we've got x plus b over 2a equals plus and minus square root of b squared minus 4ac over 2a. Okay, almost done. Throw this across the line, and it makes x equals negative b over 2a. There's why we have a negative b in the formula. Plus and minus square root of b squared minus 4ac all over 2a. Those are like denominators, so we can combine that into one fraction. And what have we got? The negative b plus and minus square root of b squared minus 4ac all over the common denominator, 2a. So that's the generic formula derived for any quadratic equation. By completing the square method, it works to give us this formula that we know and love. Maybe you know and love it. Maybe you've used it, and preferred it over factoring. A lot of my students will tell me they'll use this every time and forget factoring from now on. So this will always work to solve any quadratic. All right, so let's use that. Do a couple of problems with the formula. That's the rest of your homework, I think. There's maybe one more, maybe one at the end. I'd like to do this different, but okay, so the quadratic formula first requires that the equation be in standard form. So we need to throw this across the line. You might be getting dizzy from that at this point because we go back and forth with these forms. But to use the quadratic formula, you do need the constant on the left side. Everything needs to pick a side. It needs to be the square term, the middle term, and then the constant equals 0. You can also reduce these equations. You should have a fraction in an equation. You'd want to clear your fractions or decimal, or if it's reducible in any way, manipulate it to get it in its final clean standard form. Once it's in standard form, we consider this the a, so a is 1 in this example. B is the middle coefficient, what's in front of the y to the first. And then c is the constant. And then we plug those values into the formula. The formula, remember, tells us to take the opposite of b, so if b is already negative, it changes it to a positive. Then we are to take the square root of b squared. Now, whenever we plug this b as negative 14 in, it does need to be considered in a parenthesis because the negative is part of the variable we're plugging in. It will become a negative squared, a positive number, so that's important. I sometimes see that mistake. So it's always best to use parentheses around whatever you're plugging in for a variable if you're in doubt. Here it does matter. Negative squared is going to make that positive. So we got 14 plus and minus. I'm going to use my calculator and see what's under that radical. So I've got negative 14 that's squared minus 4 times 1 times 47, which is 8. I made my line way too big. 8 will reduce. It's not a perfect square, but it can be broken down into a 4 and a 2. The square root of 4 comes out as 2. So a lot of 2's here. We got 14 plus and minus. That would be 2 in and a 2 out over 2. All of these reduce by a 2. Remember, this is divided and this is divided. So you want to pick something that works for everything. So we can divide all of that by 2. 2 into the 7. 14 is 7. 2 that 2 and that 2. We don't bother what's under the radical because it's of this term. So you don't want to double dip there. But is your final answer 7 plus 7 squared root of 2. That's an exact answer. All right, we'll pick back up on that in the next video.